My name is Derek Johnson. I'm the product manager for Redis at ObjectRocket.
So I'm Jesse Lovelace. I'm a senior software developer at ObjectRocket.
So security with Redis is a little bit of a different animal because of the way Redis was designed. Redis is very much about performance, very much about fast reads and writes. Anytime you design something for performance, you have to not design for some other things. There's kind of a continuum there.
For the most part, Redis relies on having the Redis server behind some sort of firewall or extended application stack instead of actually trying to do the work of providing a strong layer of security in Redis itself.
It's designed to be fast, it's designed to be lightweight, it was not designed for security. And if you look at the documentation on Redis, it articulates that very clearly, that look, this isn't designed with security in mind, this is designed with performance in mind.
So there's quite a discussion about whether Redis should actually beef up its own internal security systems or if it should remain a very fast in-memory data structure server and just focus on that primarily.
Anything big that we do natively within Redis itself is going to potentially have an adverse impact on performance.
And there's different camps about this, but I think the general consensus is that keeping it as focusing on being a very fast in-memory data structure server is a way to keep it being very good and very powerful in what it does specifically.
And so that's one of the reasons why we do the things that we do around security with our product, is that we know that, again, Redis was not designed for security. So there's some additional steps that we need to take place that are recommended through the Redis documentation and from just our best practices.
So today, ObjectRocket Redis supports security by, of course, having a very simple authorization string that you have to use in order to access the server, but it also supports access control lists, which are implemented as firewall rules, which allow you to specify which host can actually contact the Redis instance. We also have the service net, which allows you to run Redis within a private virtual network that is not accessible from the outside internet.
SSL encryption will work from a customer perspective in that we are trying to make it as easy as possible for the customer.
When they create a new Redis instance in the dashboard, they'll be able to see both their normal connection strings and also a second set of ports for an SSL. And in order to do that, since most Redis clients don't support SSL natively, they'll need to use some sort of SSL tunnel in order to forward their Redis traffic over an encrypted connection.
With the kind of the dynamics of the types of use cases that are coming about and how much more complex they are and the types of customers that are interested, it made sense for us to offer an SSL encryption capability. The types of customers, if you think about like government agencies, if you think about financials, you think about people that are interested in security, but then you also think about when you start dealing with larger enterprise companies or enterprise type customers, their requirements from a security perspective are going to be a little bit different than maybe your smaller company or your mid-market. So anybody that is interested in that next level of security to ensure that their data is encrypted over the network would be interested in this feature.
Redis itself, the server, doesn't support listening for SSL connections natively. And so what we have to do is we actually have to tunnel SSL connections and then forward them to Redis at an endpoint that's very close to the Redis server. So the way we pull that off is that we have a proxy, which is an SSL compatible proxy that listens on an SSL port. The client connects to that port, we verify the certificates, we create the SSL connection, and then that's where the SSL connection terminates. And then the Redis traffic is forwarded directly to the Redis server from there.
The steps that a customer will go through in order to implement or use the SSL encryption for ObjectRocket Redis is pretty simple. The customer will be presented, when they create a new instance, the customer will be presented with SSL enabled connection strings. And all they have to do is take that SSL enabled connection string and put it in their config file, or have their app use that connection string to communicate with the Redis database. The only other piece that they'll have to do is download a certificate to make sure that whenever they do connect via the client that they've got the right cert in place. But it should be very, very simple in terms of within the UI, they're going in, they see the connection string that's an SSL connection string. They'll still have the old connection strings that aren't SSL as an option to use as well. But they'll see that SSL connection string, and they'll just use that within the app to point to the Redis database. So we did some testing here, and there absolutely will be a performance impact. Anytime that you, again, implement a security procedure within the process, our expectations are that there is going to be a latency impact. The testing that we did showed less than 5% latency impact in terms of a rise in latency, but customers should always do some testing before they put any kind of an SSL encrypted solution in place before they put that into production.
Modern CPUs and operating systems have very fast SSL libraries, and so once you've done the initial SSL handshake, your data flows at almost normal speed. And so as long as you're keeping your connection strings open, you're not going to really notice any difference. Now, if you are constantly creating and disconnecting from the Redis server, you are going to notice that additional overhead of having to redo the SSL connection handshake every time.
There shouldn't be any other feature limitations whenever a customer uses SSL encryption. We designed it such that we weren't going to limit any other features that we already offer today. And moving forward, the goal is, as we continue to add features to the platform, that we're not going to keep customers from being able to use those features just because they're using the SSL encrypted connection strings. Right now, the plan is that it will be available in all DCs that we offer Redis. So SSL will be offered in all DCs. Right now, we offer Redis in our IAD data center, our DFW data center, our Chicago ORD data center, and our London data centers. And the encryption connection strings will be available in all of those.
So SSL for Redis will initially be available to all new instances that are created. We do have plans to shortly enable a migration of all legacy instances to the SSL, which should incur no customer downtime.
You know, we have to keep an eye on this, and we have to listen to our customers as it relates to what's next for ObjectRocket and security. One of the things that we've talked about internally is we're encrypting data across the network. So it's from the client to the endpoint. One of the things that we've talked about is potentially taking that further into the Redis instance itself through the rest of the architecture. We've talked about any kind of encryption at rest or any of those other things that need to come about. We'll continue to have those conversations. We'll also be listening to our customers and seeing what's going on within the community from Redis as a whole, and we'll make some adjustments. But right now, we're focused on being able to provide SSL encryption across the network and looking at that next steps as we go.